Hello, dear students, and welcome back to my YouTube channel. This is Saramboy, your amazing prof in electromagnetics. In this video, you will learn how to use the differential elements that we have discussed in the previous topic in the calculation of line integrals and surface integrals. Line integrals and surface integrals, on the other hand, are essential because we will use them to calculate electric flux, electric currents, and magnetic flux in our succeeding topics. I will first discuss the concepts and later give example problems in which we will evaluate line and surface integrals. If you're ready, let's begin. Starting with a line integral. So first, let's define what a line integral is. The line integral of vector A is the integral of the tangential component of A along a path L. In integral form, this is written as the integral of A dot dl. So here, we have the vector A, which we will dot with dl. In the definition, the line integral is the integral of the tangential component. So, when we dot the vector A with dl, we get the component of A that is tangential or in the same direction as A. Okay, so for example, we have here a curved path. This is the path L. Now, let us have an infinitely small portion of L which we label as dl. So this is our dl. Now let us have this vector A. Okay. For example, this is our vector A. So we can always resolve a vector into two parts, the tangential component and the normal component. So if we resolve this vector into its tangential and vector component, its tangential component will be this. This is the tangential component of vector A, and on the other hand, this is the normal component. Now, when we get the line integral of vector A, we actually use its tangential component and multiply it with dl, and then after that, we integrate. Okay, that's why we say that the line integral of A is the integral of the tangential component of A along the path L. So again, when we dot A with dl, we get the component of A that is tangential to dl, okay, as illustrated in this diagram. Now, if the path is closed, the line integral becomes a contour integral, which is read as the circulation of A. So we write the circulation of A in this manner, okay? We just put a circle in the integral sign to indicate that the path over which we are integrating is a closed path. For example, we have a path from here to this point, and then another path from here to this point, and then another path from this point back to where we started. So here, we have a closed path. If we evaluate the line integral of a vector over a closed path, then that gives us the circulation of A through that path. To evaluate that, we will get the line integral for each segment. So in this case, there are three paths. No? So this is the first one, the second one, and the third. So the circulation is the sum of the three line integrals. So, di ba madali lang? Does that sound easy? Yes, madali lang yan. So, saan ginagamit ang line integral? Okay. Now, here are some of the applications of the line integral which we will encounter in electromagnetics. First, work is the line integral of the force along a certain path. So, in our discussion of the dot product, we define work as the dot product of force and displacement. No? But more specifically, work is the line integral of force. So here we have work which is equal to the integral of f dot dl, or simply the line integral of f. Another important application of the line integral is in the calculation of electric potential. Okay? So the potential difference between 2 points is actually the line integral of the electric field. So here, the AB is the potential difference and E is the electric field. So remember, the potential difference is the line integral of electric field. And remember, work and potential difference are both scalar quantities because we obtain them from that products. Remember, that product is a scalar product. Now, this potential difference is what we commonly call the voltage. At yan yung voltage na sinosolve nyo sa circuit analysis. Now, let us solve an example to illustrate how to evaluate line integrals. Okay, so here we are given the vector f, which is equal to x squared ax minus xzay minus y squared az. Now, calculate the circulation of f around the path shown. So, since this is a circulation, then we need to add several line integrals. In the illustration here, we have a closed path. There are actually four paths. The first one, the second one, the third, and the fourth, which leads us to where we started. So the circulation of F must be equal to the sum of four line integrals. Okay, so f dot TL1 plus the integral of f dot TL2 plus the integral of f dot TL3 plus the integral of f dot TL4. So we have four paths and each path has its own TL. So for the first path, what is our expression for DL? So we can see here that the first path is along the x-axis. Therefore, dl1 must be equal to dx along x-axis. Now, for the first line integral, we will get the dot product of f and dl1. So if we dot f and dxax, what will be left is just the vector component for ax. Why? Because ay.ax is 0 and likewise ax.az is also 0. No? So ang matitira lang dito is yung x squared. Okay? So let's do that. The integral of f.dl for the first path is equal to x squared ax dot dx ax. So we know that ax dot ax equals 1. And now we have the integral of x squared dx. Now, let us indicate the limits. Here, the value of x is 1. And at this point, the value of x is 0. So, we now integrate this. We get x cubed over 3. Okay? So, if we evaluate x cubed over 3, our upper limit is 0. So, it will be 0 minus 1 third, which is equal to negative 1 third. So, this is our first line integral. Now, for the second path, let us evaluate the line integral. Now, what is our DL for the second path? DL2, okay, the path is along the y-axis. So, DL2 equals dy/ay. Now, for the second line integral, if we get the dot product of this f and dy/ay, ax will vanish and at the same time, az will also vanish. And what will be left is just negative xz. Okay, so here we write negative xz times dy. Okay, so yung ay, ginawa ko na lang 1. Now, let us indicate the limit from this point. The value of y is 0. And at this point, the value of y is 1. So from 0 to 1. So here, our variable is y. Okay? But from this point to that point, the value of x is 0. And the value of z is also 0. Therefore, the line integral along this path is 0. O, di ba? Dali lang? Okay. Now, hindi mo na malayan natapos ka na pala, 'di ba? Let us evaluate the line integral along the third path. Lipat tayo sa kabilang slide, okay? So in the third path, we see that the path has a component that is along the axis and at the same time along the x-axis. So our DL3 must be the sum of dx ax and dz az. So dx ax plus dz az. Again, why is that so? Because the third path from this point up to that point has a component that is along the x-axis and at the same time a component along the z-axis. So, if we get the dot product of f and dl3, so ay will vanish. So now, let's write down what will remain. So, if we dot f and dl3, this will remain. So, x squared dx and this one also minus y squared dz. So now we can separate this into two integrals. The integral of x squared dx minus the integral of y squared dz. Now, let us indicate the limits. For dx, what is the value of x from this point up to that point? Here, x is 0. So from 0, at this point, the value of x is 1. How about the limits for the second integral in which our variable is z? So at this point, the value of z is 0. And at this point, the value of z is 1. So from 0 to 1. Okay? We can now integrate. So evaluating the first integral, we will get x cubed over 3. So if we evaluate that from 0 to 1, we will get positive 1/3 and then minus. Okay, so in the second integral, our variable is z. However, here we have y. Now, if we look at the path from this point up to that point, the value of y is constant, which is 1. Okay? So here, y equals 1. So we just substitute y equals 1 here and we will get dz. So the integral of dz from 0 to 1 is just 1. And 1/3 minus 1 is negative 2/3. Okay? So we now have the line integral for the third path. Okay, now how about the line integral for the fourth path, which starts from here and ends there? Okay, now let's define DL for the fourth path. If we examine this path, it has a component along y and at the same time a component along z. So DL4 must be dy ay plus dz az. Now, if we get the dot product, f dot dl4, ax will vanish. Okay, so anong matitira dyan sa loob ng integral? Ang matitira na lang ay negative xz dy minus y squared dz. Now, we separate these two integrals. We have negative of the integral of x z dy minus the integral of y squared dz. Now, let's indicate the limit. From this point, the value of y is 1. And at this point, the value of y is 0. For the second integral here, z is 1 and there, z is 0. So 1 to 0. Here, the variable is y because we have the differential dy. How about the value of x and z? Okay, now if we examine the path from this up to this point, we have a constant value of x which is equal to 1. Okay? So, x is equal to 1. How about z? Okay. So, z is changing from 1 to 0. Okay? So, z is also a variable, but our variable of integration is y. So, how do we relate z and y? We need to express z in terms of y. So how do we do that? So if you examine here, the change in z is equal to the change in y. So therefore, z must be equal to y. Okay? So thus, I can replace this with 1 and this, I can replace it with y. Integral from 1 to 0 of y dy minus the integral from 1 to 0 of. So let's do the same for y squared dz. So here, the variable of integration is z. Thus, we need to express y in terms of z. Again, what is the relationship between y and z? So again, z is equal to y. That's why we can replace y with z. Okay? So this becomes z squared dz. So we can integrate. Now, if we integrate, we will get y squared over 2. Okay? So if we evaluate it, upper limit minus lower limit, we will get 0 minus 1 half. Okay? And then minus z cube over 3. Again, if we evaluate it, upper minus lower limit, 0 minus 1 third. Okay? So this becomes positive 1 half and then plus 1 third. Okay? So we have 1 half plus 1 third, which is equal to 5 over 6. Now, to get the circulation of F, remember that the circulation of F around the closed path is equal to the sum of the four line integrals. Ano yung una nating nakuha? Negative 1 third and then 0. So we have negative 1 third plus 0 followed by negative 2 thirds and lastly 5 over 6. So plus 5 over 6. Okay, so if we add all of this together, negative 1 third minus 2 third plus 5 over 6, this will give us negative 1 over 6. Okay, so that's it. We're able to get the line integral of this vector f around this closed path. Okay, so let us see. If we get it right, ayan, tama naman po. Nakuha natin ang tamang sagot, di ba? So ngayon, marunong na tayong mag-line integral. Di ba? Madali lang. Madali lang yan, promise. Walang kasing dali. So kayo lang ang nag-iisip na mahirap ang electromag, kayo lang ang naiisip na mahirap ang vector calculus. Madali lang yan, promise. Testing nga. Halimbawa, ito yung path. No? Ano ang DL sa path na ito? Diba? So if you examine this path, it has a component along x and a component along y. So in that case, yung DL natin ay dx ax plus dy ay. O di ba ganun lang kadali? Yes. So now, let's solve another example. This time, let us find the circulation of A in the given figure. So here is the figure, and A is a vector equal to rho cosine phi A rho plus Z sine phi AZ. Okay, so the vector is in cylindrical coordinate system. So therefore, if we evaluate the line integral A that dl, so its circulation, A and dl must be in the same coordinate. Okay, so that they will be compatible. Again, if A is in cylindrical coordinates, then dl must also be in cylindrical coordinates. But here, we have this figure. Okay, so how can we relate this figure to cylindrical coordinates? So if I will draw a cylinder here, so, of course, we know that the top surface of the cylinder is a circle. So, if we view the cylinder from the top, so what we will see is the top view. Then, we can relate this figure. No, this figure is actually a sector, okay, which is a portion of the circle. Okay, so that means that this segment or path is along the radius of the cylinder. So, it's dl is equal to d rho a rho. And this curved path would have a dl equal to rho d phi a phi, and of course the dl for this segment is also d rho times a rho. Okay? So now that we have defined the DLs for each path, we can now calculate the line integral. So for the first path, we will get the dot product of vector A and this DL. So this term will vanish because if we dot A and A row, what will remain is just the vector components for A row. So I will write it down here, rho cosine of phi multiplied by 0. So here, the variable is rho and phi should have a constant value. Okay? So along this path, the value of phi, of course, is 0 because it's along the x-axis. Okay? And let us indicate the limit. The limit for rho is from 0 to 2. Okay? From 0 to 2. So, cosine of 0 is 1 and this becomes the integral of rho 0 from 0 to 2. Okay, now let us evaluate the integral. This becomes rho squared over 2. So, the upper limit is 2. 2 squared is 4. And then, divide it by 2 minus 0. So, the answer is 2. So the line integral for the first segment is equal to 2. Now, how about for this second path? For the curved path, we need to again get the dot product of A and DL. In this path, DL is rho d phi times A phi. But in the vector A, there is no A phi. So if we get the dot product A dot DL, we will get 0. Okay, o di ba? Ang dali. Walang kahirap-hirap. Yung line integral para sa curved path na ito, yung L, it must be 0. Now, we calculate the line integral in the third path, which is from here to there. So, DL is also d rho a rho. And the integral becomes rho cosine of phi 0. What is the limit? The limit will be from 2 to 0. But in this path, what is the value of phi? The value of phi is 60. Phi equals 60 degrees. So, cosine of 60 is 1 half. So, this becomes 1 half times the integral from 2 to 0 of rho 0. O, di ba? Dali lang? Yes. So, mag-integrate tayo. Rho squared over 2. So, it becomes 0 minus 2 squared is 4 over 2. So, here we have negative 2 divided by 2 is negative 1. Okay, so now we are ready to get the circulation of A. So, the circulation of A through this closed path is equal to 2 plus 0 plus negative 1. So, the answer is 1. O, di ba? Dali lang? Yes. Ni hindi mo na namalayan, tapos ka na. Okay, so that's it. Yan na po yung line integral natin. So, tama kaya ang ating sagot? Yes. O, di ba? Hindi na nga natin 'to nasulatan, eh. Kasi dun pa lang sa first slide, nakumpleto na natin yung solution. Which means, hindi naman gaano kahirap itong line integral na ito, 'no? Sabi ko nga sa inyo, mas mahirap pa yung mga expressions na ini-integrate mo noon sa integral calculus. O, di ba madali lang? Yes, kaya hindi niyo dapat katakutan ang electromagnetic. Tanggalin niyo na yung, masamang impression sa subject na ito kasi ito ay interesting na subject, no? So, sa ngayon, medyo marami tayong math na inaaral pero later on, mas maa-appreciate nyo yung mga math na yan kasi gagamitin natin sila sa actual electromagnetics. Okay? So, our next topic is about surface integral naman.